Welcome. Dear students, today we are going to discuss Markovnikov's rule. To have a much better understanding of what Markovnikov rule is, please refer my earlier video, Addition of Unsymmetrical Reagent to a Symmetrical Alkene. Meanwhile, in this video, let us focus our attention on what is Markovnikov rule. So let us start Markovnikov rule. My question to you is, what would happen if an unsymmetrical reagent reacts with an unsymmetrical alkene? I repeat, what would happen if an unsymmetrical reagent would react with an unsymmetrical alkene? I take the example of an unsymmetrical reagent HBr, and I take the example of an unsymmetrical alkene, which is the simplest example of an unsymmetrical alkene is prop-1-ene or simply propene. So what would happen if I react it with this? Okay, so to know it, we need to know the nature of these two reactants. This is an alkene. It has one sigma bond and one pi bond. The pi bond actually exists as an electron cloud above and below the plane of the molecule. So the alkene is actually an electron rich compound. Now let us look at HBr. HBr is a polar compound. It has sufficient dipole in it. What is the meaning if it has dipole? It means that it has positive as well as negative charge. It's polarized. So one day there will be a moment when this will get dissociated and H plus will be released in the system. The H plus released is the electrophile because it has positive charge over it. And what would the electrophile do? Obvious, it will attack the pi cloud. And why? To take a pair of electron and become neutral. When it attacks, actually it has two options. Okay, either it can take pair of electron from this carbon atom, or it can take the pair of electron from this carbon atom. Now the question that comes to our mind is, from which carbon atom would the H plus take the electron pair, or to which carbon atom would the H get joined to? This question was actually answered by Vladimir Markovnikov, who is a Russian chemist. Markovnikov stated that H plus, or the positive addendum of a reagent, or an electrophile, whatever name you want to say, you can say that the H plus or positive addendum of the reagent or the electrophile, it goes to that carbon which already has higher number of hydrogen atoms. That is, case 2 occurs. Case 2 occurs. That is, H plus or electrophile or the positive addendum will go to that carbon which already has a higher number of hydrogen atom. So accordingly, what he stated is that the major product that will be formed, this is addition reaction, everything gets added. The major product that is formed will be this. What is this? Isopropyl bromide. Isopropyl bromide. That would be the major product. Major. And the minor product, a very little quantity of N-propyl bromide will be formed. Very little quantity of N-propyl bromide will be formed. So that will be our minor product. So this is what Markovnikov stated. H plus, the positive addendum, will go to that carbon which already has a higher number of hydrogen atom. That is, in this case, it will go to this carbon atom. And accordingly, Markovnikov said that the major product will be formed. Here in this case, isopropyl bromide is the major product and N-propyl bromide is formed but in very few quantity. So now the question that comes in our mind, the actual question that comes to our mind, which is of grave importance, is why does the H plus goes to this carbon atom, to the carbon atom which already has a higher number of hydrogen atom? Why does the H plus come here and join here? Why doesn't the H plus go here? So that question's answer we will come to know when we study the mechanism. So let us go into the mechanism. Mechanism, as we have seen, electrophile has, in this reaction we are seeing that electrophile is getting added to the electron cloud, and Br is also getting added. So it is totally an electrophilic addition mechanism, and electrophilic addition mechanism has three steps. Step number one for ionization of unsymmetrical reagent. Ionization of unsymmetrical reagent. What is unsymmetrical reagent here? Yes, what is it? Correct, HBr. This is positive, this is negative. I already said that there is a dipole in this, and the dipole is sufficient enough as to them to get dissociated. Now in this step, the electrophile has taken birth. Now it needs to attack the electron rich alkene. That attack we will see in step number 2. So step 2, attack of electrophile. Let us see. Step 2, attack of electrophile E plus. You can write full E plus. Okay. Let us write the unsymmetrical alkene, which is the substrate on which the attack should occur, and let us like the electrophile. Now the H plus wants a pair of electron. It can attack the pi cloud. Either it can take the pair of electron from this, as we already stated, or it can take the pair of electron from this. So this is case 1 and this is case 2. Let us see what would be the carbocation that we get in case it attacks this carbon atom. That would be CH3, CH2, CH2 positive, because this carbon lost its electron pair to the hydrogen which got attached here. So positive sign comes on this carbon atom. And let us see what happens if case 2 occurs. CH3, CH, CH3, and positive sign comes here because this carbon loses the electron pair to the hydrogen which gets attached here. The positive sign comes here. So in case 1 we can see this carbocation. In case the H attacks this carbon, this carbocation results, and in case the H plus attacks this carbon, this carbocation results. Okay, this is primary carbocation and that one is secondary carbocation. Can you say which one is stable? Which one is stable? Is the primary carbocation stable or is the secondary carbocation stable? I say that the secondary carbocation is much stable than the primary carbocation. And why? Because there are R groups. R groups are actually electron pumping groups. They pump electron, they donate electron. And there are 2 R groups on either side of the positive carbon. So what these R groups will do, they will pump the electron, okay, and this pumping of electron reduces the positive sign here. It will reduce the density of the positive sign. It will reduce the magnitude of this positive sign, and that would lead to the stability of the secondary carbocation. That would lead to sufficient stability of secondary carbocation. While in this case, there is pumping on only one side. They all pump towards this direction. So the efficient decrease of this positive charge is less as compared to this. Efficient decrease of positive charge is not seen in primary carbocation. But in case of secondary carbocation, there is pumping from both the sides, and that would lead to a significant reduction of the positive sign here. So the secondary carbocation would be more stable than a primary carbocation. And therefore, and here we got the answer already. It is of surprise. We got the answer, and therefore H would attack the carbon atom which already has a higher number of hydrogen atom. Case number 2 occurs. Why? Because secondary carbocation is more stable than the primary carbocation. The secondary carbocation's formation is favored. Okay, and how will the secondary carbocation be formed? It will only be formed if H plus attacks that carbon which already has a higher number of hydrogen atom. And therefore Markovnikov rule states like this. Okay, so we now know that secondary carbocation will be formed as major carbocation and primary carbocation will be formed in minor quantity. Let us go to step number 3. Step number 3 is addition of nucleophile. Addition of nucleophile. Okay, which is the major carbocation that is formed? The secondary carbocation. Let us write that. So this is the major carbocation, and which is the nucleophile in the system? Br minus. And what will be formed as the major product? Yes, we got isopropyl bromide as the major product. Isopropyl bromide. And why we got isopropyl bromide as the major product? Why did we get isopropyl bromide as the major product? Because we got secondary carbocation as the major carbocation. And why secondary carbocation was favored? Or because it was more stable. It is more stable than the primary carbocation. And therefore H plus. And how this secondary carbocation will be formed? It is favored, right? And how will it be formed? If H plus goes and attacks that carbon which already has a higher number of hydrogen atom. So this is why Markovnikov stated this rule. Dear students, I hope you understood the class. If you like the class, please do not forget to subscribe the channel. Thank you very much.